All righty, welcome back, everybody. I hope everyone else feels energized as well after that keynote, and very happy to introduce Juha, who is going to talk about data models as the business-friendly interface for data catalogs. Juha is the Chief Product Officer at LE Technologies, and before that, he was in charge of information architecture at UPN. So welcome, Juha.
Thanks, Steve. Great to be here. So let's get started. What we're going to be talking about today is perhaps a topic that we've kind of touched upon a few times during this conference, which is how data models can be like business friendly. They are for the business and by the business, and they describe the business. And I think there's a interesting use case regarding data catalogs here. So what we're going to be talking about in this session here is first super brief introductions. I'll promise to keep it brief. This is not advertisement. A few points about how data catalogs usually work nowadays. It's a hot topic. Everyone is thinking about getting a data catalog. Many organizations have their own data catalogs. Many of our clients have their own. The rest of them are all talking about it. And then a few points about how these data models are really sort of a simple way to describe business assets, and then how you can use data modeling techniques to figure out basically how your data assets look like. And this is the way of approaching this metadata that you gather in your catalog in a way that makes it approachable and understandable for human beings. And in the very end there, I will also share a few words about perhaps the vision that we have over at Ellie regarding this kind of metadata mess that we live in. And I think I promised Steve that if there's like any interesting questions in the chat or anything, you can interrupt me. I also try to preserve some time in the end for Q&A. So let's see what it looks like then. I guess without further ado, let's get started. So just a brief introduction. Juha Korpela is my name, complicated Finnish name, Chief Product Officer at Ellie Technologies. I'm running basically the product development in Ellie and kind of doing this methodology thing, being the kind of modeling guy there. I've been in this business for 10 plus years now, as Steve mentioned at UPM and as a consultant and whatnot. You can hit me up in LinkedIn or anything. What Ellie as a company does is Ellie does this, well, basically the only product that we have and the only thing we do is Ellie, the data modeling tool. And now this is not just an advertisement, this is actually relevant for the context of today's presentation. We aim to make this tool such that it is fast and easy and understandable and simple to use. We want to use Ellie as a tool basically to make data modeling the means of communication between IT and business people. And this, of course, leads to the realization that, okay, we have to build a tool that is so easy to use that it doesn't get in the way of this communication. So super fast, super easy, completely cloud-based, no installations, nothing, open your browser, there you go. Again, not an advertisement, but relatedly, Ellie does model design, of course, yes. But what we have is a glossary which is interlinked with the models. Not only interlinked, but I would say even completely the same as the models. So the glossary in Ellie contains all the entities you've ever added in any of your models, and these entities know that they are being used in different models. So this gives Ellie basically a centralized repository of models and entities that are all interlinked, and this kind of gives you this overall view of how things are linked without even going to individual model diagrams. Perhaps I can show you how that works in a moment. However, a couple of words about what we want to do with this is that, of course, now collaboration is key. So getting the business involved, making it easy enough to understand so that we can get that understanding of what is truly going on, as we've been talking about in throughout this whole conference. And then, of course, integrations so that the data models themselves, the metadata that you've gathered, can be utilized in all kinds of projects, data warehousing, master data management, whatever that is. So This is, of course, a type of metadata management ideology here, what we have basically. And to get us closer to today's topic, what we face in many organizations is kind of a messy world of all kinds of metadata. I've just grouped here four kind of groups of metadata that we can identify. This is by no means a kind of scientific classification of metadata items, and there's no fancy framework behind it, but just in terms of everyday things that we face in different organizations when we try to look at what we actually know about our data. We have the tables, columns, and schemas or whatnot. We have the obvious physical metadata that often is super interesting for the data architects, the technical guys, and the engineers and DBAs and whatnot, but which is quite difficult for anyone in the actual business process to understand. On the other hand, we have people and organizations and roles and responsibilities. We know something about, Steve is responsible for this data set here, and we know that um, Barbara owns customer data, or we know that someone is an expert in something. We know how the organizational structure is built. We know what the teams are, and so on and so forth. We perhaps know that someone is the main person responsible for personal data, so on. And as another group of things, we have rules and policies that we try to define that limit and perhaps also enable data usage. We can say that there are certain rules on how personal data should be utilized, where you can use customer-specific transaction data, how public data can be utilized, and so on. And then we have the core of this conference, which are the business terms and definitions about things, with the idea that what does a product mean? What does a customer mean? How these are linked? What is an invoice? How do you get the invoice from the sales? How many factories do we have? Stuff like that. So the actual concepts of things that happen in the real business. So usually what happens now, and I've done this in previous employment at a relatively large company, that we start figuring out, okay, well, we have all this metadata. So how do we keep track of what is linked to what? And the usual solution here is that, all right, we'll set up a data catalog. Now, what the data catalog usually does is that it gathers tremendous amounts of technical metadata through all kinds of very clever integrations, automatic crawling of databases, whatnot, where you can get the technical metadata regarding the tables and columns and schemas and files up from the systems into your catalog solution very easily. Of course, there's the hurdles of firewalls and whatnot, but the process of integrating those tools and ingesting this technical metadata is in the end relatively straightforward. So data catalog vendors, they put a lot of effort on this, and many data catalog projects also focus first and foremost on getting the technical metadata in. Then they start figuring out that, okay, well, now that we have this here, perhaps we should think about data governance. So let's create some rules and policies, or figure out what rules and policies we have, and let's link those with the technical metadata items that we have. Let's figure out who the people are involved. Let's figure out who the data owners are, and let's assign the data owners to all of these different technical metadata items we have. And perhaps they even have someone who is rather interested in what things really exist, and they start working on a business glossary or a thesaurus, as we heard about yesterday, and they start figuring out what are the core terms that we have in this business. So they realize that, okay, customer means this and whatnot, and they start linking that kind of flat glossary list, like many of these data catalog tools have, with the tables and columns and schemas, saying that, okay, this table contains data about vendors. This table contains data about deliveries. That's good. Now, what happens when you create a data catalog solution like this is that you are creating a registry of all kinds of metadata, and then you are building this kind of what I'd like to call a Wikipedia-like structure, where you have articles of individual metadata items. This is the table here. This is the person who is data owner. This is the rule on PII data. And then you have kind of hyperlinks between these articles, like you do in Wikipedia, saying that, okay, Steve here is responsible for that, and then there's a policy on usage of that data, and these are linked like this. But it is always centered around technical metadata, and this reason is of course twofold. First and foremost, the data catalog providers themselves put a lot of emphasis on getting the technical metadata in, and secondly, as we've seen and discussed this and laughed about this a few times already, uh, this is also heavily influenced by IT thinking that, of course, the databases and contents of databases are going to be the center of everything. So the catalogs are excellent at registering and listing that technical metadata. What they don't do very well is giving business context. They might list your business glossary items and business terms and so on. That might be a full list of 100,000 items, and you might be able to link those individual items to individual things. But it doesn't really well explain to you what do you do with this data that is about deliveries. How does it actually connect to anything in real life? Well then, on the other hand, what a good conceptual data model is, and I'm using the term conceptual data model here in a very inaccurate way. Uh, I'm using it in the sense that Alex Sharp has, for example, described there, which is a description of a business in terms of things it needs to know about. Missing a word there, I think. Or another quote from Graham Witt saying that it is a narrative supported by a graphic, which means that we have a model of reality model that explains how things in reality are interlinked and how these things in reality, what sort of definitions they have. So what is the nature of the relationship between customer and an invoice and a product? So this is technology independent. It is excellent way of depicting what the relationships and structures of this data are in a visual way. And what this is, in terms of allegory, maybe, this is like a map. Your data catalog with its technical metadata is like Wikipedia, but what a good conceptual data model is, it is a map of how things are interrelated and what are the core entities that form the, let's say, cities and towns of your map, or the nodes of your network, if you'd like to look at that way. And when a conceptual data model, or whatever you want to call it, this sort of model which tells us about the true reality of what is going on in the business rather than a technical implementation, when that is a good model, it is kept simple and it is kept focused on the business. These two kind of attributes of a data model, so to speak, are something that is often not very applicable to data catalog solutions. We've seen over and over again that a data catalog solution built on top of a lot of technical metadata and that automatic ingestion of the metadata is not very simple to understand, and it is not focused on the actual business. Okay, let's park that thought for a moment. So what we do with Ellie, and now this is semi-advertisement, but this is still very much related, is we're trying to create these models that are simple to understand, that are focused on the business. So you have entity relationship models, simple but powerful models. You have entities there, you have relationships, you have a description of the relationship saying that the person here is responsible for a store, maybe they're a manager or something. You have the cardinalities, so one to one, one to many, etc., etc. And one extra thing, which is the color codes here, which are what we call entity types that you can categorize that, okay, well, these are by their nature kind of master data type, and these are kind of reference data, that is a transaction, and so on and so forth. This is, again, not a fancy theoretical framework, but just a best practice style that we've seen works quite well in many cases, makes the models easily readable and understandable. The key here is that every single entity in this diagram is not just a box with a label on it, it's an entity in the glossary. So Ellie's glossary then is basically a list of all the possible entities that you've ever added or that you will add in your models, with each entity being, of course, unique in that glossary. So once you create your product entity, you will always use that same product entity in all of your different models. This kind of reusability then means that Ellie can track how you're reusing these models, meaning that the product entity, for example, here we have a small screenshot. I'll actually show you how that looks like in real life in just a moment, is used in a couple of models, and we can track how this entity is being linked to other entities across all of your models and display that information already in the context of the glossary itself, not just in the model diagram. So you're kind of getting this holistic view of all your core data entities and the interrelations between those in the glossary, even if you were modeling the kind of whole enterprise picture from just small pieces here and there. So let me very, very quickly show you what that looks like in actual Ellie. What I have here is an Ellie environment running on my Chrome browser, and we can see a list of models. Let's have a look at a healthcare model here. So this is a rather nice model, I would say, so about healthcare things. And we can see that we have persons and customers and employees and so on and so forth. As I double click on the customer entity here, I can see that this is the glossary entry for the customer. So I've defined what the customer means. It is someone who buys our products, etc., etc. Well, that's not actually very sensible in the healthcare context, but in any case, we can add examples, we can add synonyms, whatnot. We can add attributes if we'd like so. And here we can see the relationships that the customer entity has in this example environment of Ellie. So you can see that it's being used in 3 different models: customer template, simple sales models, and healthcare example. And we have links that this customer has to different entities across all of these models. So we're in effect defining that, okay, our healthcare data looks like this. We have different sorts of entities. The customer entity looks like this. This is how we define it. And this is how it's related to everything else. And we can navigate that, okay, well, let's look what the company looks like. Okay, company is linked to other entities like that. Contact person is linked to everything like that. And that's used in customer template model, which look like this. So everything here is interlinked, and the models themselves describe the data content, as Alex said, the information or the business in terms of the things that it needs to know about. So pardon me. So this is a simple way of describing your data asset. Now, the question remains then, so what are you saying, Juha? What is this whole thing about? What I am saying is, why wouldn't we actually then utilize these very simple diagrams, these very simple glossaries and so on, these conceptual data models, to define what the data is about first, and then link everything else to that? So if we have good data models, and if we have a strong data catalog, which contains a lot of all kinds of metadata about your technical systems and roles, responsibilities, and whatnot, let's combine these two. Let's create a powerful combo that is accessible from this kind of perspective of interrelated data models, and then this kind of technical ingestion of massive amounts of metadata. And we've actually seen this work at a couple of clients now recently, clients that have been setting up massive data catalog projects and at the same time have been building up the conceptual data models, their kind of enterprise level understanding of what is going on, and linking those together. So how does that happen then? A good way of approaching this has been, for example, this is actually from a real client, although those pictures are not from a real client. We are defining data assets. We call them data assets. You could call data assets, data products, whatever, but we have been calling these data assets. The key thing here is to ask, what are the data consumers actually interested in? They are not interested in database tables. They're not interested in reports. They are certainly not interested in JSON files in a data lake folder somewhere. They're interested in questions like, I wonder how much we're spending money on road-based transportation in Germany, or which customer segment might be the one that we should aim our advertisement at. So these are the real questions about real life. So we need data to solve those questions. Let's define the data assets that the organization has in those terms. So we're calling logistic data asset a collection of things like routes, vehicles, destinations, deliveries. Perhaps we would have like running costs or something if we are interested in the costs of that logistical operation. And we can combine these customer related things that we model as a customer related model into customer data asset. We're saying that customer data asset consists of people, organizations, segments, addresses, whatever you have relating to customers. And we're using conceptual data modeling techniques and of course Eli as a tool to specify the things that this data asset is about and how these things are related to each other. So in effect, if you remember the Graham Witt quote there saying that a data model is a narrative supported by a graphic, we're kind of replicating the narrative part of the data model here, just by defining our data assets in terms of these terms and their relationships rather than in terms of tables and databases. So this could be the logistics data asset. We reveal what the core entities are, what the relationships are by doing just creating a simple data model. It doesn't actually even matter if it's in Eli or any tool. Any tool, you could just do it with post-its like on whiteboard or whatever. We want to understand what are the things that we're interested in this logistics space. And we define that logistics data asset is made of these things. So it is a group of entities that are interrelated and that as a group are valuable for some business purpose. So we create a model of that group of entities, and then we can register this group of entities, this data asset, in a data catalog. Now, we have been working with catalogs like Colibra's data catalog, for example, where there are kind of pre-existing, let's say, buckets of metadata in the catalog itself, where we can directly plug these entities and models into. While it is also possible to customize many of those catalogs in such a way that you could create this kind of new metadata asset type, which is data asset or data model or so on. The idea being that this data model defined this way is the business-friendly entry point to the mass of metadata that you have in the catalog. So here, I think this is perhaps the single most important slide of this presentation, where I try to explain the approach. So comparing now two different ways of building a data catalog. What we talked about earlier there was a kind of bottom-up data catalog where we focus on getting the technical metadata in and we link everything else to those technical metadata items. What I am proposing here is let's turn that around. Let's focus on getting the data assets, so to speak, right, the data that we know business is actually interested in, customers, products, logistics, and so on, figure out what those are actually containing, what are the things that we have data about, what are the real life things that we're actually interested in, define those as kind of data assets, business data assets, whatever you want to call it, and utilize that as kind of higher level business metadata into which we then start linking things like uh, roles and responsibilities, people, systems, tables, policies, rules. By doing this with conceptual data modeling techniques, we can actually approach this from a far more business-friendly direction. If you consider now that you take your controller from your finance department and tell them that, okay, well, you need to create a report about the top 10 customers in specific segment in specific area with specifications about products and whatnot, and you go and tell them that, hey, okay, all the data that you need is defined in our data catalog, then I would dare say that this sort of an approach would be far more easier for them to understand than this sort of an approach. However, often we are offering them this, and then we are wondering why are they not interested in our data catalog. Now, again, using the logistics data asset as an example here, what we could do is basically for each entity define that, well, the vehicle data here comes from the vehicle tracking system. Also, the trips are there, the actual journeys taken. The deliveries are transactions which are relating to the customers. So regardless again of the actual underlying techniques or technologies or anything, we can already say that for delivery data, that being a customer related transaction, we have a policy that has to do with that. And the policy might define that, okay, you're not allowed to show this to anyone who isn't working with the particular customer or market or whatever. And we can say that, all right, well, we have a logistics data owner who owns everything in this. So all the logistics data asset, and we can define that ownership already on this level of conceptual entities rather than we figuring it out on a system level. We can, of course, then start linking these entities to systems, saying that vehicle data and trip data are in vehicle tracking system, destinations and routes are in our logistics planning system. But if we define the policies and ownerships and stuff on conceptual level first, we actually make this far more easier for the data owners and other people interested in this data in the business to approach. So basically, how this works then is that we can first start with trying just the basic modeling stuff that we're all talking about here. Try to understand what the business is about. All right, define then the kind of meaningful data assets based on these actual existing business domains and terms. And by a meaningful data asset, I mean that what is a kind of group of data entities that are kind of related to each other, and that as a group provide some sort of value to the organization. We could say that logistics data is one. We could have customer retention data, or we could have product master data or something like that, which is a group of entities that are related that define an asset that is valuable as it is. And then we figure out the actual model of that. So we identify that, all right, well, we have defined that logistics is interesting. So we want to figure out what our logistics data is made of on a conceptual level, identify the core entities, identify the relationships, and create this model in such a way that everyone can understand it, everyone can access the model, which is, by the way, one of the key things in Ellie, that everyone can access the model and see for themselves what this system, that's good. But we can also do it on a more granular level, saying that, for example, this particular data entity lives in this system, but it is also being used in systems B and C, and so on and so forth. Or we could even go a slightly deeper level and say that we have information about vehicles in these 3 reports and these 4 database tables. But whatever is the nature of the link between the kind of conceptual data assets that we've created and the technical systems we have, it doesn't really matter, because we have defined the governance, the rules and policies, roles and responsibilities. We have defined those already on the conceptual level. This is very, very important in the sense also that if we consider data governance as something that we want to do, and we should because of GDPR and whatnot, we should consider that the rules relating to customer data should always be the same for all customer data, if that is what the law demands from us, and it should not change based on the system. However, I have personally seen situations where, for example, GDPR compliance is figured out on the basis of systems, and you are basically listing that, okay, well, this system is something that has to do with GDPR and that doesn't, and so on and so forth. So it's like a wrong way of approaching this, approaching it from the entities that we are interested in and that the law is interested in is the correct way of setting up the governance, and then figuring out where that data might actually live. So what's the benefit then? Of course, the key point of this whole talk here, we get the data catalogs to become more human friendly. So when a person who is not a technical data person approaches the data catalog, they have an idea in their mind. They want to find data about logistics costs in Germany at a certain period of time relating to certain kinds of transportation means and routes. And they have that idea in mind, and then they face the data catalog where they should find it. So why would we force them to translate their idea into something that you know something that we have thought might be a good way of organizing the catalog, which usually is systems and tables and so on? Why doesn't the data catalog give them the access at the level of thinking that they are actually doing, and then giving them access forward from there, from this kind of conceptual level to technical and technical items and rules and policies and whatnot. So allow them to access with the thought in their minds that I'm interested in logistics, give them logistics, and then let them navigate from there to something more detailed. I think this is actually quite critical because I have this kind of lingering feeling that quite a few data catalog initiatives are going to be failing in the next couple of years, caused by the fact that the data catalog is far too difficult to approach, and this means that it doesn't actually bring any additional value. I do like the idea of data catalogs. I have to say that I am really fond of it. I just think that it has to be done in a human-friendly way. An important thing here is also in setting up the actual data governance scheme. There are different ways of doing that. We've all probably heard about non-invasive data governance, which is a great thing to have, but there's always the kind of problem that where you are talking about data to people who are not, data people, but the non-data people are the business people who actually need to care about the data content. So you can find the data owners, the data stewards, usually from the group of people who are not interested in databases but who are interested in logistics. So you have to be able to discuss with them on their own terms, and you can reach this level when you have functional data models, when you have the data assets defined, and then you can start figuring out the ownership schemes. This I have personally seen to be working quite well. We are lowering the kind of level of expertise that is needed to be able to discuss data governance. And that brings in more business people who are interested in the actual data content. Another interesting thing is that we have the map. If you remember, I told that I see data catalogs traditionally as Wikipedia-like and data models as map-like. And discovery of data that is related to the things I have now in my hands is far easier with a map than with kind of this Wikipedia-like linked articles. The issue here is that many data catalogs are very, very capable of producing data lineage in the technical sense, that it starts from here and then it goes to that system, and they can even read ETL scripts and whatnot to figure out how the data has been changed and so on. And perhaps they have this ability to show you kind of a map of a physical data item, a table or so on, and then you have the business term that is linked to it perhaps. But what they are not very good at is displaying information on kind of horizontal view, so to speak, saying that I am now interested in routes for logistics purposes, but is the route actually like theoretical route that I can take, is there a difference between a route, a journey, and a trip? How are these related, and how do they relate to the actual vehicles that travel that road? This kind of map and thinking about the relationships between the same level of entities is something that data models really do. So discovering data that is related somehow to my customer entity or something is far easier with data models than it is usually with kind of your normal technically oriented data catalog. And here, if you remember from the brief demo of Ellie I gave you, you can see that we've already gathered that sort of information into the tool itself. So you can see, if you have your customer entity, you can see what are the different things that link to the customer entity. This enables you to basically innovate on this. So you can figure out, oh, I didn't even know that customers are linked to, you know, um, claims or something like that. I wonder what claim data we have. This is far easier to do based on data models than it is based on the technical data catalog contents. And lastly, an interesting thing and something that we've been involved in at a couple of organizations has been this kind of data mesh type of thinking from the point of view of data products. If you have defined that this is what my logistics data asset looks like, and you have figured out how it links to different systems, and you have figured out what are the rules and policies relating to it, then why not also give the physical data in that format? And what we've done at a couple of places looks something like this. So business users are using conceptual data modeling and LE, of course, to define their data assets. That, okay, well, it looks like this. And the data asset, which with its entities and relationships, is stored basically, of course, in LE and synced from there to a data catalog where the mapping between the conceptual entities and technical entities exists. So the mapping is done in a catalog, and the catalog can then be there might be custom scripts or all kinds of API management frameworks, whatnot. It doesn't really matter what the technological solution is, other than it is very, very much possible to then automatically generate a data product endpoint, which might be an API, which might be a database or whatever, which basically presents the data from the complicated technological sources in a format that the business users understand. So utilizing conceptual data modeling to basically describe what the data asset is as you understand it, and then mapping it to everything else enables you also to use the data in that format without any care of the actual source system, problematical source system database structures and so on. So I think this is something that we're going to be seeing more and more, and certainly something that is, I think, at the core of the whole data mesh thinking. We have to be able to define data products that are understandable and that kind of hide away the technical complexities of source systems. So in an ideal world, all of this different metadata, be it technical metadata, conceptual business metadata, people, policies, and so on, would be interlinked and easily navigable. And we would be able to approach it from either the side of the systems and the techniques and the technicalities of tables and databases and so on, or from the side of the business, from processes, perhaps from entities like routes and journeys and trips. Now, what we want to do as a company, Ellie is a great tool for conceptual data modeling, and the glossary is great. What we want to do in the future is that we want to focus the kind of metadata navigation around these easily understandable conceptual models that provide the business context that is usually missing from all kinds of technical metadata solutions. We feel that this business context that easily made conceptual data models can provide is something that should always be at the center of everything. And then start adding these kind of metadata linkages around these conceptual entities in in a way that makes the navigation easy. So we want to actually, in the future, especially We want to help people to navigate the messy world of metadata, and we want to help them create more metadata and create linkages between metadata entities and so on. We have this kind of internal buzzword. We are talking about intelligent modeling, and that might be very much the future of Ellie. We want to be able to interpret the network of these metadata items and provide new ways of navigating that and provide new ways of creating more metadata. So what we have as an internal vision kind of is called Google Maps of metadata, where the visual navigation that always relates to the business context in the center of it is the way to traverse the information that a catalog might be. For example, if you have one, that a data catalog might gather that information, but we are providing the map for navigating that. So that's basically the idea here. Now I think we have time for questions and answers.
Thank
Do we
you,
have
Juha.
any,
That was
Steve?
pretty good. Yeah, that's great. The question I have is when you're working with clients and you're creating the data model first and then you have the mapping to the catalogs, should that data model reflect how things are currently in the client site, or is it sometimes reflect how they'd like it to be at some point in the future?
Excellent question. Excellent question. I don't have a silver bullet answer for that. I think that's a bigger question actually, is that do we even want to model things as they are, or are we always aiming for the to be
Mm,
state? It depends on the situation, I would say. One interesting thing would be to figure out that the kind of entities, do the entities remain the same, and are the relationships just changing? So
mm,
the glossary itself could kind of be stable. You always have customers and products and invoices, but you might have new ways of linking your customers with the deliveries via some sort of intelligent delivery system in the future. So are you actually going to just, add new relationships to those models, giving you new ways of navigating that metadata in the future? I don't see why you wouldn't do that then already. You know that, okay, this sort of relationship is going to appear. If you have something completely new in your business, like you're getting a entirely new division to make something different that no one else has been doing in your company earlier, then yeah, it might be a little bit weird to be modeling like things into your data catalog, things that don't actually link to any physical data yet.
interesting.
But I do think that the relationships between things are super important, and that there can never be too few or too many. I mean, too many relationships. It's always a new path of traversing the map, really.
Thank you. Thank you for that. Couple of questions too. So, one from Stephen Beckman. I may have missed it. How do you navigate from a data catalog to the data product itself? That is, link to download CSV or an API or some BI tool. So, how do you have those linkages? Interesting.
Yeah, that depends on the data catalog, really. So what we have seen, for example, is that the data product as it is defined with a conceptual data model in Ellie, for example, and the information about that model is brought into a data catalog. And in the data catalog, it is linked with data sources and so on. And if that generates then a data product, we could bring that metadata about the data product. It might be an API endpoint, for example, as additional metadata attribute into the catalog. So if we create an API from this data product, then the data product in the catalog shows that, all right, here's the API from which you can approach this data. So we can also bring that data back up to Ellie, of course. So it's just, I would say that the specifics of how to connect into the data product are just more metadata, again,
Mm,
linking to the exact same product.
thank you. Thank you. And question two from Magnus. Can you import existing conceptual data models from another tool like Power Design or Irwin, Spark CA?
Into Ellie, the Models themselves, not yet. The glossary is fully like import export capable, so you can export and import to your heart's content. But the model diagrams themselves are at this point still something that you have to create within Ellie. I do believe that that will change at some point in the future. We do want to have these sorts of integrations so that people can move away from their old systems to ours. But right now, you still have to create them in Ellie.
I noticed that the modeling tools are really good at getting data into their tool from other tools. Yeah, yeah, yeah. There was a comment earlier too, not a question, but a comment just about how there's lots of different terms for the same kind of concept, like conceptual data model, sometimes concept model, sometimes
Yep.
conceptual model, information model, data catalog could be a business glossary, data dictionary, some kind
Yep.
of combination. Yeah, so really an interesting comment as well.
Yeah, I think that's quite problematic for us, really. That I'm talking about conceptual data models here. Someone else is talking about information models. We basically mean the same thing, but for an outsider listening into this discussion, they might get a little bit confused.
Yeah, yeah.
I don't have a kind of personal paradigm that I would be following. I try to use the words that people tend to understand.
That's the best way to be. Yeah, always thinking of the audience, like what kind of terms would they like to see? Yeah. Well, I'm a fan of Ellie, so if she, I don't know how many people who are in the session have played with it yet or are using it, but it's really I like its simplicity. I like how it kind of fills the gap between the data glossary and the data model. So very cool. Any other questions? All righty. Well, it's a perfect time to break. So thank you very much, Juha, for the wonderful session.
Thank you.
And
Thank you, Steve.
we'll